Okay, awesome. Yeah, thanks for the introduction. Sorry, it's morning here and a little nervous, so we'll see how this goes. But yeah, as Brooke kind of mentioned, I'm really passionate about the technology, oddly enough, and I'll explain more about that. But hopefully, we can take away some really cool stuff about how this applies to coral reef restoration. So that's the focus of this talk. Um, I'll give you a very, very brief 30-second rundown of myself for those of you who don't know me. I do want to give a super quick 30-second crash course of photogrammetry just because that's what we're going to be talking about. And then I want to touch on, restoration, touch on how restoration is difficult, as many of you know, but photogrammetry can actually help quite a lot. And how can you do this? And then give some of my concluding thoughts. Um, so I somehow ended up here. Basically, to give you a map, I'm not really a good person to talk about myself. So I grew up in the San Francisco Bay Area. I know we had Monterey, I believe that was Kurt, so great for attending. But I grew up in the East Bay, kind of east of Oakland, it's a city called Pleasanton. So San Francisco is easy to remember. And then eventually I ventured out to college, to university, attended university having no idea what I wanted to do, took 2 years off and did some volunteer work in Brazil, came back and spent the next 5 or 6 years basically spinning around, trying to figure out what I wanted to do, change my major a bunch of times. But eventually I graduated and I wanted to explore kind of marine science, coral reef ecosystems, something along that. So ventured out here into Hawaii. I put 1 for 6 because now I have no shame, but I applied to 6 graduate schools, got denied from 5 of them, but later found out the one that accepted me had a 100% acceptance rate, but I'll take it. Sometimes you need those easy doors to walk through. And that I came across photogrammetry, learning about how it was used in other technologies. And then also how, researchers here in Hawaii and other parts of the world were kind of experimenting and applying it to coral reef work and research, which was really cool, a nice coincidence. I then began to work at the Hawaii Institute of Marine Biology, working for a lab there, Josh Maiden's lab, and then eventually started with the Coral Resilience Lab, which I work with now, been there for a few years. And then throughout that process, I started Settide, and I'll go more over that. And that's where we are today. So very, very simple crash course. If you have any other questions about my background, I don't know how interesting it is, but feel free to ask. So what is photogrammetry? I understand there might be some people who have no idea what it is. There might be some people who've heard of it and others who actually use it and are applying it, which is great. So just to kind of get everybody on the same even playing field, photogrammetry actually in the word itself is using photos to collect measurements. There's really cool history about it. It's said to believe to have started with like Leonardo da Vinci, kind of theorizing about it, but it really kind of came to be in the 1800s from this man, Albrecht Mettenbauer, who kind of became the father of photogrammetry. He was an architect, and then somebody else in France who was simultaneously working on like land surveying, and they were trying to understand taking photographs and collecting information about that. Modern photogrammetry is more three-dimensional. So basically there's a 3-step process of how do you get from photos to these 3D models or images and collect measurements. The first step is you take photos of the object. And I don't know, this might date some of us, but those old flip books kind of where you like fan through the book and it's like a stick figure moves little by little, kind of walking or running. That's kind of the photos you're taking. You're taking a photo and then you're moving little by little around the subject or object. You can do that with your phone. You can do that with a camera, with a drone, anything that has a camera to it. Step 2 is how do you convert those photos into 3-dimensional digital objects like models or larger scale maps, images. You do what's called 3D reconstruction. And there's very different algorithms and processes, but basically the computer, and its magic behind it, detects features from one photo to the next. And it matches those features together and starts to recreate what you took a photo of in 3D. So it's really cool. You can use lots of software. I will primarily mention Metashape and a computer. There's even some apps to do very, very simplistic forms of this. The third thing is you get some kind of output. You get, what's called a point cloud, which are points in 3D space kind of floating around, making it look like that 3D object. You can get imagery maps like that DEM colorful image on the middle left, or an orthomosaic, a larger map, or like a 3D model. And then I'm going to add the fourth step, which is what we're also going to talk about, is collecting data. Lots of other industries use this, but we're going to also use it for collecting data. There's kind of two main general types of photogrammetry. There's aerial, which means you've got your camera up in the air. You've got a drone. You've got a manned aircraft like a helicopter or plane. You've even got satellites, which is snapping pictures of the Earth. Or you've got close range, which is a camera or its sensor, and you're obviously very close. Like I said, you can take your cell phone and walk around in the yard or scan, some building or a car or something like that and recreate it. And then also underwater, which is what we're going to kind of focus on. The reason I'm kind of giving this little very crude crash course is because I do want to preface into photogrammetry is actually a very well-established technology. Yes, there's experimentation and new research and people trying to really push it forward, but it's been around for a while. Obviously, 1800s and so on, but modern photogrammetry, the last couple of decades, with the advancements of computers, it's a very well used technology. If any of you listened to the Apple keynote, Apple, big company Apple, about a week or so ago when they launched, their new iPhone and all their new stuff, they kind of gave a 30-second tidbit on when they were doing their AirPods. So, being able to listen, and noise cancel and stuff like that. But they use 3D photogrammetry to scan the ears of people to be able to understand better the shapes of trying to create a better headphone, arguably better or not. So it's a very well-established technology, which is really cool. But these are some examples of what it's used. Museum artifacts, aerial imagery. I did a project working on boats where they had to scan the deck of the boats because they wanted to get it to millimeter precision of putting like solar panels on them, which is really cool. And coral reef habitats and stuff like that. So lots of really cool stuff you can do with it. So going into kind of coral reef and how it's applied there, I kind of wanted to touch on that monitoring restoration is difficult. And with my limited experience, and there's probably people on this call that have much more experience than I do in the restoration space, but I kind of tried to break it down. There's lots of things you got to do even before you start restoration. You got to get permits or permission to access that place. Yeah, the elephant in the room, you got to have funding. You got to have some kind of financial support, large or small. Operations, boats, equipment, again, getting access to the site, weather, depending on where you are, you got to travel. Scalability, how large of the reef you want to monitor or the number of sites. Number of staff and students, the feasibility, can you even do this again? There's lots of behind the scenes work. And then when you finally do restoration, if you think about it, the first question you ask is, did this work? Did what we do anything? If you're out planting corals, for example, did they attach to the reef? Did they survive? Did they start to grow and contribute to the reef, whether that's physically, structural shape, whether that's genetically, spawning and things like that. There's, again, I'm sure I'm barely scraping the surface of what we really ask, but then the question is, can you do it again and again? Can you do this long term? And what restoration project progress really needs is to be validated with good data. There's climate change, there's urban development and anthropogenic or human stressors, on so many reef habitats around the world, that are affecting it faster and faster. We've heard that story, time is of the essence or time has passed, but no matter what, you need to validate your work with good quality data. And so kind of trying to, again, this is very scraping the surface, but where is restoration in terms of monitoring now? People still do, visual estimates, go down and dive and write things down, how the corals are looking, how the reef is doing. That can be very subjective. One person may see one thing, another person may see another thing, different trained eyes. People are taking photographs, maybe even videos, but you don't capture the whole reef, maybe you only capture focus sections. It's a bit slower. It can be technically invasive. You're introducing transect tapes and quadrats and maybe other equipment. Not as efficient. It's difficult to compare with others. I think I'm kind of, hitting the nail, and there's probably so many other things. It's good. It's gotten to where we are today, but really the methods of data collection can't keep up with what we need. And so we need both high quality and larger quantities of data to be collected to be able to help answer a lot of the questions. And so this is where actually photogrammetry can help quite a lot. It provides the tools that we've been missing. Photogrammetry can improve the quality, it can improve the quantity of data collected, and it can actually improve the efficiency of your logistical operations. These are just a few bullet points of kind of some of the ways, again, from mostly my experience or other people that I've had the privilege to work with of what they've said, how it's helped. But the quality of your data, you have much higher accuracy. You don't have to rely on 2 or 3 people, and there's still added value to some of the previous methods, like visually going down to the reef and observing it. Oh yeah, there's still lots of value to that in certain ways, but being able to collect actual measurements of the coral. What is the shape of the coral? How is it growing? What's the surface habitat it's creating? Down to millimeter, sub-millimeter precision and accuracy, which is great. You can scale that. You can get larger quantities. You can not just monitor 10 or 20 corals. You can do hundreds of thousands of corals or a much larger reef habitat area. And the logistics of it, I would argue, are actually like you had to do like a cost benefit or kind of trade-off. You get a lot more return for what you put in. It might look like a little bit more effort, but you get, I don't want to use the word exponentially, but you get a lot of return off of that effort that you put in. You get 3D maps of the reef habitat. You know, you can GPS position that, so you know exactly where every single coral is, how it's growing. You can create archived maps of the reef, and I love this, and I'm going to share some examples of it. That can be really useful for community and education purposes. There's so much that we'll talk about, and again, there's much more that I won't even have the time to talk about. So look at some examples of how photogrammetry is being used to improve restoration monitoring and data collection. A lot of these examples I'm going to share are graciously, I've been working with the Coral Resilience Lab the last few years, and they've been doing really awesome restoration work, focusing mostly here in Hawaii, you know, trying to understand how corals can possibly be thermally tolerant to different, you know, temperatures and environments here on the islands. But I'm going to present some of those examples. So the first is monitoring corals ex situ, kind of in tanks or aquaria or land-based nurseries. The next is monitoring outplanted corals, colonies or fragments and reef habitats. And then third is kind of how it improves data collection. So this is actually kind of a really cool thing that I've been able to experiment recently in the last year or so, but you can monitor corals ex situ. You know, you can have corals in tanks or nursery or aquarium setups, and you can capture kind of those coral first. So if people are here working with spawning, say for example, like the Coral Resilience Lab does a lot of great spawning work. And you need to understand, you know, lots of the spawning and genetic side of things, but also how are the corals settling and how are they surviving in your tank systems and things like that. I'm sure many people here know better than I do how much work and effort that is to count corals and be able to do a lot of just the basic first layer of data collection. You can take a camera, you can snap photos of these corals. You can do it in a kind of fancier setup where you get really high resolution cameras, or I started out leaning over a tank and putting my camera in the water and taking pictures as best as I can of those corals settling. And you can get really cool information. So here's an example of coral juveniles that are about 3 months old. This was from an experiment kind of before they entered into kind of a temperature stress treatment to see how they would come out. But first and foremost, looks really cool. You can capture some really cool imagery with it. But second, you can understand, like on the right, those corals are fusing together. When they grow, how much larger do they become? Then you can explore more about the 3-dimensionality of these corals. How are they growing compared to maybe their adult counterparts? There's lots of cool information to be, I think, explored about this, the survivorship, the shape and color. So this is kind of a first example of seeing this, of how photogrammetry can be used for kind of coral babies, coral juveniles. The next, which might be a little more common, is kind of like coral fragments or coral colonies. Is again, as long as you have a camera and you can take pictures of these coral fragments, either in the tank or briefly bring them outside in the air, you can use a nice multi-camera system that the Coral Resilience Lab has, or we start out with just a single camera, you know, and spinning around the coral or having the coral spin and take some photos. And you can be able to recreate that coral in 3D, which first looks cool, but second, you can get actual three-dimensional information about it. What's its branching pattern? How are these corals growing? How is the color changing through time? What's the volume? Things like that. Maybe you're trying to understand how these corals are doing in your nursery setup before you outplant them or put them wherever else you're going to do. And capturing those 1 6-month year, whatever growth rates, and compare them to kind of the more natural growth rate in the wild might be really good information. It can give you feedback information about your tank system setup, how the corals are doing, probably other biological questions that are way above my head that you all can answer better than I can, but you can capture some really cool information. Then when you actually outplant these corals into the reef, which hopefully we get to that point and they do well and they survive, you can monitor them. And this is, again, one of the projects that CRL has that we've been doing here in Kaneohe Bay on Oahu. We started collecting them in March 2023. I actually just went out to monitor these guys about 2 weeks ago, but haven't had time to make the 3D models of them yet. But just visually, you can see, wow, these corals are growing, which is great news, in the world of often hearing sad news. But on top of that, again, you can collect millimeter precision, accuracy data of how well are these corals growing. Not only can I see in the bottom left picture that that coral is growing and it looks to be thriving, but how is it attaching to the reef? Do we expect it to break off, as corals often do, or will it remain, and so on? And you can compare this to whatever your experimental setup is. This I do by basically taking an underwater camera down, taking photos of it, bringing it back to the computer and collecting that data. But lots of really cool stuff you can explore with this. For this particular project, there was a pretty good survivorship percentage. They've been growing about 4 to 5 times their initial size, which is awesome. And that's just with about a year's worth of data. So I'm sure a lot of you have other great projects and really other cool data to share, which is great. But this is just one of the things that has really helped us kind of understand these types of outplanting projects better. And then obviously, I think what many of us maybe have heard is that you can monitor entire coral reef habitats. So this is just an example of 2 reef habitats here on the south shore of Oahu that we've actually been monitoring for the last 4, almost 5 years now. So it's kind of almost, turned into a long-term monitoring project, at least here in Hawaii. And you can measure the growth and survivorship. You don't have to visually check all the corals. Each of these reef sites, depending on the size that you have, can take anywhere from these take about 4 to 5 minutes. And yes, I've timed myself about 4 to 5 minutes to photograph. And if you do larger areas, maybe 10 to 15 minutes. Logistically, that's you in the water spending 5 minutes photographing. Even if there's a little bit of current, even if the visibility isn't the greatest, you're not bringing down transect tape, you're not bringing down quadrats, you're not trying to, you have to train a little bit, you obviously have 2 people down there, but it's logistically a lot more feasible. You can bring the images back to the computer and spend a better time and get better quality information, being able to look at this imagery and models. Something really cool that was kind of not of our focus is that we've seen reef habitat structural change. So this is an example of here, another site on the south shore of Oahu, where the left image, these are digital elevation models. So maybe preface with that. So these are images that instead of the pixels having color, like we take photos, they have pixels of height or altitude information. And this kind of gives it a cool 3-dimensional look. So you can see the topography and the structure of the reef, but kind of in 2D, which is really cool. And so you might be able to see kind of 2 boulder-ish size. I don't have the scale up here, but those were like about 2 meter by 2 meter kind of boulder size, kind of in the top left of the left image and the bottom left. And then about a little less than a year later, we went back and realized, hey, they're gone. And quite a few of our corals and other things were affected. And there was a big swell and kind of a storm that came in. So just being able to track that natural reef disturbance that kind of occurred was really cool. For this project, we've been monitoring a couple hundred coral colonies, 85% survivorship, which is great. And they've grown, many of them double or triple in size. And this is based off of 3 years data, and we're collecting our 4th year. So you can really scale your operations, which is really cool. So I've been talking a lot, and kind of, again, I apologize, kind of breezing through some of these examples. There's so many other ways that you can incorporate it. But let's say you figured out, okay, Spencer, I figured out how to take photos. We got our nursery tank system set up and we're capturing and building 3D models, or we're going out to our reef sites. We're surveying the area. Great, we've got a couple months or layers of imagery and 3D models. How do I collect the data, right? And that's exactly kind of where I was a couple of years ago of like, how do I collect this useful information, this useful data, much more than just visually looking and saying, yep, it seems like the coral's doing great, or I don't know, they're not doing so well. And I kind of ran into this problem. Collecting data from monitoring restoration is fragmented. What I mean is it's broken up into a lot of pieces that don't really fit well together. And you're often left having to fend for yourself. You might export, those top two images here on this slide, the nice colorful digital elevation model, and the one on the left, orthomosaic. You might use that to collect larger scale data, and you export it to one program to get, I don't know, maybe an estimate of surface area. Maybe you export it to another program to estimate, topography and stuff. That involves you learning multiple software, and then you got to figure out how that data is collected, and if it's up to par to what you need, and there's just kind of a lot of mix of stuff. Maybe with the 3D models, you got to export it to another CAD or engineering software, which is often complex in its own right to learn. And you're collecting bits and pieces of data from different places. And myself, I was like, I can't do that. I would like it to be all in one place. I'm not much of a coder, or, a developer or anything, so the least amount of coding I can do is great. But yeah, there's a lot of issues that I was finding. And so this is kind of where I started having the beginnings of Add Tools for Metashape, which is a custom software I create to provide tools in the photogrammetry software in Metashape. It's kind of like a plugin, but it gives you additional tools to collect data. I really was creating this for myself. I remember sitting in our, at the time, studio apartment, and I just needed to collect distance. I just needed to get the distance from one point on the reef map to the other, but accurate, because I was trying to think georeference or something like that, put GPS points. And doing that manually and drawing like a little makeshift ruler on the software program, it doesn't really get you to centimeter, millimeter accuracy that you want. And I remember I figured out how to do it, and a little box popped up and gave me the sub-millimeter precision of this distance. And I was like, wow, that's amazing. And so I started building other tools that I was really using for myself. And then I started sharing them with other people, and it kind of snowballed from there. And so this is a really cool software application that it just gives you extra buttons to click. No coding involved. Don't really need to learn that much. It's very similar to how you already do things in Metashape, which I think a lot of us already work in to build the 3D models and imagery. So why not do everything at once? I mean, most people when they cook, this could be a horrible analogy, but most people when they cook in the kitchen or wherever you're cooking, right? You don't cook on the roof or in your car, hopefully not. So doing it all in one place. And this is what we've been really implementing with a lot of our restoration projects. Again, the Coral Resilience Lab and some other organizations I've worked with. You can export this data into a nice Excel sheet, and then from there you can analyze it how you want. Easy to learn, easy to train others. You can scale your data collection. So here's some popular tools. I think right now I have 15 to 20 tools available, but one of them is called Measure DEM. And this is probably really applicable to a lot of restoration projects. So when you go out and survey the reef and you collect imagery of, whatever your reef site is, and you come back and want to collect data about maybe the habitat, the size of the corals, etc., you have these large files in the bottom left, that elevation map. Maybe you have specific corals that you can trace and annotate, which you can do in Metashape already, and you want to add category information, like if it's bleaching, what species is, and so on. Then you can click some of the buttons here in this middle box shown. I want the surface area, I want the volume, I want the topography, I want this, I need it in meters. Export it, please. Go grab a coffee, go grab whatever you need, work on other information, and then it'll export that as an Excel file for you. For 3D models, so for people maybe working in like nursery tank systems, research designed or outplanted coral fragments or colonies, you can already in Metashape, you can say you go out and you photograph 100 coral fragments. You can build 100 of those coral fragments all at once into 3D models. And then now with Add Tools, you can collect data of all 100 of those coral fragments at once. Again, exports it into a nice Excel CSV file. Another cool one that I think might be useful is shapes info for people who might be doing random point analysis. Maybe you've got an imagery of a reef habitat map, and I know there's some protocols that you want to put 100 or 500 or 1,000 just random points and get an idea of like the benthic kind of composition, sand, rubble, hard coral, soft coral, whatever. There's a tool that you can create those random points, and you can click on each one and add whatever information you want, and then export that information, which is really nice, again, to do it all in one place. So that is kind of some examples of using photogrammetry for monitoring with some example projects, and then hopefully, being able to make collecting data a little bit easier, more feasible for a lot of us. So then the next question could be, how do I do this? How do I get started? Or I've kind of started, how do I implement some of these things? The first thing is obviously learning what photogrammetry can do. There's equipment involved, and camera and software and computer. Thankfully, a lot of software is just clicking buttons, so not a lot of back-end stuff. Learning how to build the 3D models and imagery, and that goes into project planning, the number of sites, how many corals you want to photograph, and the size of the area, and then collecting data. If I had to summarize this into kind of two things, it's how do I do this? And then what is best for me? As I've been doing this over the years, I've quickly learned that everybody's projects, as much as we're collecting a lot of the same information, how the coral's doing, are they growing, and so on, all of our projects are very unique by design. Some of us are just starting out and maybe only have one specific reef spot that we have access to. Maybe we don't have fancy camera equipment or a fancy computer or anything. Whereas some of us maybe have been doing this for a few years and we've got a lot of different types of equipment. So that's something that I also really wanted to help people with, is helping people across the entire spectrum of how can you do this? And that's, again, what really has been helping shape kind of this other venture of mine of Settide, is being able to help people do more with this technology, photogrammetry. It's already well established, like we talked about early on. It's thankfully much smarter people than me work on it and push the boundaries further, being able to advance the technology even more. I just want to bring the puzzle pieces and put them together to make people who work in this industry hopefully easier. I know a lot of us have other stresses on our jobs, and adding another tool can kind of be stressful, but hopefully, with the resources that Settide provides can help people. So provide training and consulting and workshops, direct services. I've had people who say, hey, we just have all these photos, but we don't know what to do with it. Great, give them to me. I'll do the rest. For those of you who are doing it yourself, there's ad tools for Metashape, helping you collect data, and some other cool tools to help you streamline stuff. I am an authorized Metashape reseller. I've actually had people verify this. They emailed the company saying, is this legit? And they emailed back and said, yes. So I love that. I love fact checking. But I provide discounted Metashape licenses on my website, trying to create as many learning resources as I can. So I have a guidebook that's like 80–90% done. I need to update the data collection section, but basically from start to finish, how to use photogrammetry and coral reef habitat work, to giving you a crash course photogrammetry like I just did, to what buttons do you press to help build models and imagery, to collecting data, and so on. It's a guidebook. It's not telling you exactly what you should do because it's very flexible, but hopefully it points people in the right direction. And I'm going to make some tutorial videos as well. Got a few old ones up. And then courses. I provide one-on-one kind of training and courses, but also online courses. I know there's people who have organizations or students and sometimes having that flexibility of being able to take those courses and kind of help you get started is what people need. So this is kind of one of the things that I've been culminating for a while to hopefully help people in this industry, push their work a little bit more forward. There's a dedicated website page for coral reef habitat work on Settide's website. There's other tools. I'm trying to implement tools. I know a lot of people ask, how much does this cost and how long does it take to implement? I've got some basic tools on there that you can choose from a few popular cameras or a few popular computers and stuff, kind of get an idea of what this costs. To answer maybe some people's questions, it's upfront cost, but then you have those things forever. It's not like a subscription type thing or whatever. It's kind of buy any gear that you have. But when I teach people who are just getting started with photogrammetry, I just ask them, what do they have available, and to use that. You could have the world's fastest car, but if you don't know how to drive fast or use it, then it doesn't make you the fastest driver. So, working with what you got is most important to start out. On the website, there's the guidebook as well, where you can click through sections and hopefully get some nice help. I'm always looking for feedback for what works and what doesn't work, because again, everybody has so many different projects. And so hopefully I can make it to where it's a resource that people can come to as they need and be able to refer to. So yeah, I feel like I've been talking a million miles an hour, but hopefully we'll try to kind of wrap all this up. The main focus I wanted to, and hopefully came across, is that photogrammetry improves coral reef restoration monitoring. It is a well-established and flexible technology. I gave you guys kind of a few examples, and there's so many more that maybe even some of you are using or know people who are using, but you can use it from the day or months that the coral has come to be and settling, to outplanting or any type of other restoration process you guys have, to full reef scale. I've done imagery and models of kilometers of area of reef. It's a really flexible and awesome technology to use. You can validate your work. You can really collect that data to validate what you're doing. And I know when I've spoken to people who are just starting out, sometimes that's one of the many, puzzle pieces that they're missing, is to be able to say what they're doing is working, because sometimes telling people maybe doesn't come across, but presenting them with hard data and saying, here's these corals and here's how they grew and here's the scale and here's the quality, we have this accuracy, you can kind of check all the boxes that can maybe help, influence your work much further. And there's many other things, but we can create digital archives. We can have that opportunity to showcase this. I failed to mention, but when I first started working at the Hawaii Institute of Marine Biology, we were working on the 2019 bleaching event, and I was in charge of doing all the photogrammetry stuff for that. And we went to about 30 or 40 sites here in the Bay. And about 2 years later, so 2021 or 2022, somebody approached me and said, there's this invasive sponge or algae that we've noticed here in this area. Do you have any have you guys seen it? And we spent an hour or two, and I flipped through all those imagery of those orthomosaics, and we found it back in late 2021. And this was 2 years after the fact. And they said, that's great. We have like a history record of this being present in this area. I don't know how that, helped their work, but it's a really cool historical archive that you can have, especially for areas that don't have maybe these archives already made. And then lastly, hopefully concluding all this, you guys have someone to help you. I did obviously mention, the work I do for the Coral Resilience Lab and the work I'm doing for Settide, provide those resources. But I'm always here as a soundboard too. I will share my email, and you guys can always reach out to me for any questions or help that you need. So yeah, hopefully that was, useful information to you all, but thank you so much for attending. I hope we all learned something here. If we have time, I'm happy to take questions. But thank you guys for, CRC for giving me this opportunity to talk. The Coral Resilience Lab that I've been working with for the last few years, do incredible work at Hawaii Institute of Marine Biology, and letting me share a lot of this stuff with you guys today. So yeah.
Wow, Spencer, thank you so much. I'm sure I can speak on behalf of everyone on this call that we really appreciated getting this crash course in photogrammetry, hearing about your humble beginnings and how it led to starting a really successful business and research project. So I'm going to open it up for questions now. There are a few in the chat already, so I'm going to start with those. And then after that, I would recommend people to just react by raising their hand, and then we can field through questions. But just to begin, Cheryl has a question. She says, does one need to already have a Metashape license for Settide to work, or does the Settide license include everything needed? And I'm sure she could also jump in and clarify her question.
Yeah, great question. The short answer is yes, you need a Metashape license. You need the Metashape professional license. So on my website and on Agisoft's website, parent company, but if you go to settide.com, Metashape, give some more information, but there's backend tools. They kind of give a simpler version, like a small light version called standard, and then they give the full suite called professional. They do give educational discounts, and I also give those discounts. So if you're a professor or student, or you're affiliated with a research university, you get that discount. If you're a private company or nonprofits, which I know that's a lot of us, you don't. But to use the Add Tools license, it has to access a lot of the features available in Metashape. So yes, you need that as well. But feel free to ask any other questions about that. Yeah.
So the next question is from Mark Romero. He asks, is there an open source site for imagery for us to practice it? He also says, nice overview, Spencer.
Thanks. Yeah, can you repeat that? Is there an open source site for imagery? Is that what he said?
Yeah.
Yeah, so just, I'm guessing, Mark, you're asking just to like access imagery, either to play around with or work with, is maybe what you're hinting at. Sorry, I might be speaking for you.
Exactly,
There are,
Spencer.
yes. Okay, cool. Hi, Mark. Yeah, that's a great question. There are open source sites for non-coral reef stuff. Like there's a lot of cultural heritage rights, stuff like that. But obviously for coral reef stuff, NOAA has a site. Well, I'm not trying to disrespect anybody from NOAA on here, but they used to, I think, last I saw the tag was like 2000 whatever. So I'm not sure how often they update it, but it's obviously very specific to some of their projects. That's actually something I'm very interested in, that I want to kind of host either work that I produced for some of my tutorials of like, I know I teach some courses where I'm like, hey, let's do this. But by all means, if you don't have the opportunity to take a photo of this, here's a couple of photo samples you can download and you can, work with yourself. I would love to do that for coral reef stuff. I have individual coral 3D models of stuff. And then I'm working on getting access with, some people that I work with and collaborate with for like larger reef. Because I know it would save time, or at least that like cost benefit of being able to work on some of those things maybe before you hop in the water. Although it's important to take imagery yourself, but I know sometimes you want to play with the toys before you buy it. So yeah, hopefully that answers your question.
Okay, so the next question is from Jess Perilli. I hope I pronounced that right. She goes, I heard you say that you can collect enough photos for a reconstruction of a reef site area in about 10 to 15 minutes. Would this apply to a situation where you're trying to capture individual fragments on a reef, or is that the time to capture imagery for a reef site when you're just trying to do a reef site level DEM, i.e. not trying to look at growth of individual corals? She also has another question. I don't know if you want to answer all of them at once, but she also says, I'm also curious about estimates of time needed to complete a given reconstruction in Metashape, i.e. if we want to track 100 fragments, how much time would be needed for the post-processing approximately for a given time point?
You guys are asking awesome questions, so this is great. To answer your first question, kind of the time component, that 10 to 15 minutes, I was giving a very rough estimate. You're asking the question of scale. So what do you want to monitor? Individual corals, the entire reef, a little bit of both. And that gets into explaining how you take photos. This all starts with photos. So how you take photos, the quality of your photos, how close you are to the coral, your camera, all these other layers influences the data you can collect later on. So for example, if I have outplanted, let's say, coral colonies like basketball or soccer ball size or something like that, I could very much swim about a meter above the substrate and get that kind of top down, like you said, DEM view. And I can still monitor those individual coral colonies. Most of the time with your camera setup, I'm not going to promise, but probably 90% of the time you can do that. If you're outplanting little tiny fragments, I've done both. We've outplanted hundreds of fragments and we maybe subsampled and I individually photographed maybe 50 or 100 of them just for time, like you have dive time and air and stuff like that. And then I'll do a top-down kind of map to get an idea of those fragments. So there's advantages and I don't want to say disadvantages, but there's pros and cons to both ways. And if you have more questions about the specific, maybe of your project design, I'm more than happy to answer those. To move on to your second question, processing stuff in Metashape, stay tuned. I'm working on a research project that hopefully we can submit that's going to answer some of those questions about the Metashape component of like, what's the time and feasibility, but also I actually secretly built another software that was a benchmarking tool and then I like took it off. But I think I want to expand on it more. But yeah, I want to be able to provide that information of testing multiple different computer setups, multiple different imagery components, and give you guys kind of a ballpark range of if you've got this many photos, if you've got roughly this computer, it'll take about this long. But I will say there's so many things involved with that. And again, we can go more into details about that. So hopefully that answers some of your question.
Great. Okay. We've got another question in the chat from Kurt Yeager. He asks, can you recommend a camera for a student project? We plan to integrate with Blue ROV2 for surveying a reef, budget of $1,000.
Great question. Hi, Kurt. I think you're in Monterey right now. Super jealous. But yeah, great question. Recommending cameras is always iffy, so thanks for providing the budget, and by all means, let's email. There's lots of cost-effective cameras out there. I personally, and I know this might sound off to a lot of people, but I don't personally like recommending GoPros or action cameras because of how distorted the fisheye is, but it's really awesome how cost affordable they are. So I've done a lot of work with action cameras. DJI has one, GoPro, other ones, and I've made some great models. So for students or something like that, that could be a great fit. If they're not going, I know you guys are using a Blue RV2, so I'm not sure what depth you're going at, but if you're not very shallow, you can, if you feel so inclined, strap on an old iPhone or Samsung with an underwater case. There's apps that you can use to have it take continuous photos. You can technically take videos and cut them up into photos. The quality isn't as good, but if just to teach the students to get a good idea, Sony has their A series, like A6600 or A6800. Those are about $1,000 or less than $1,000. And those are about the size of like kind of the newer, bigger iPhones. So that's a nice small camera. I know a lot of people might use Olympus TG6 or 7. Pros and cons using all these cameras, but that's another, you know, cheaper one. I think those are like 550 or 750 or something like that. You have trade-offs. The age-old story is the more you pay, the more you get, and that's mostly true with cameras. So obviously, a more budget-friendly camera, you're gonna deal with that. But that's a few options less than $1,000. But let's chat more, and I can maybe point you in the right direction. So.
Thanks, Spencer.
Great. So it looks like we don't have any more questions in the chat unless I missed anything. But it looks like Steven's raising his hand right now. If you want to go off of mute.
Yeah. Hey, thank you so much. I'm so happy to have jumped in, and I'm maybe the oddball here. I'm not a scientist or a researcher. I'm an artist, but I'm working on a project that basically communicates all of your efforts to a greater public. So I just wanted to just jump on and say thank you for your work, and also that I was fortunate enough to go out with Coral Gardeners and do just this. And it's no joke. It's real work. I mean, there was a current that was really kicking, and like I wasn't shooting, I was just observing. But I totally acknowledge the amount of effort to go in, because everybody from the outside, an outsider's perspective, is like, oh, how great, you go and jump in the water and take some pictures. But it was I was beat by the end of it. So hats off to everybody doing that. And then I was wondering, maybe I'll email you and connect possibly back to the question of the models that you do have, and maybe we can talk further about kind of using those for some inspiration and something like that. So yeah. Anyway, thank you for being here, and thanks for having me.
Yeah, thanks, Stephen. Appreciate it. Yeah, feel free to reach out.
I think we've got one more question in the chat from Eric Carden. Asks, does ad tools work with older versions of Metashape? Will an ad tools license be valid for future versions?
Great question. So the first question, will it work with older Metashape versions? It works with Metashape 2.0 and above, and that's probably in this last year they've made those updates. The parent company who makes Metashape is actually really good about giving like 3 to 4 updates a year, which is nice. A lot of them might be minor, like a previous update was like LiDAR scanning and aerial stuff that might not influence our work as much, but I always recommend trying to stay up to date. It works with the 2.0 and above because there were quite a few changes made that did influence data collection. The processing is a little bit faster than like 1.8, 1.7 and before. Will it be available for future ones? Yeah, so that's right now, Ad Tools is priced to just be like a one-time license. And I obviously, this is a business for me. I got to help, supplement the development side of it. I obviously want to balance it, making it affordable for people. So buying it once, you have it forever. And then any updates I release, you just download the new version and you have a license key. I'm still kind of learning how to do that because I'm not a software developer by trade, but you have the license forever. There's free updates. There's different versions of ad tools. So go to the website to see which version is best for you. And then as Metashape updates, I'll also update to make sure it's compatible with it. So I try to keep up to date as best as I can. Hopefully that answers your question.
Ali asked the question, is it at all possible to use aerial drone imagery?
To use aerial drone imagery, and I'm going to add on for like coral reef restoration work. I think that's what you're asking, so correct me if I'm wrong. But yeah, I've heard some people of doing that. You're kind of zooming out, literally into kind of more larger scale stuff. There's obviously logistics for that. You got to have really shallow reef, perfectly glassed, still water, because you're going through not only air, but then light refracting in the water, kind of those different mediums, which is really cool for like Steven, I guess, on the artistic side of, taking photographs, but photogrammetry, that's hard. So no wind, nice cloudy covered days. Water is nice and still. I do have some colleagues that do drone imagery for that, but those are just different research questions, that you might be asking. So if you're curious about exploring that or bouncing off ideas, I'm happy to help either answer or definitely point you in some direction that might help. Yeah.
So it looks like we have time for about one more question. And if there are none, Spencer, I would say to plug yourself, how do we reach out to you? You could drop your email, plug Settide, whatever, for people to connect with you further.
Yeah. How you can reach out to me. So there's my website. I'll drop that in here. To everyone in the meeting, and then you can email me. So spencermiller@settide.com is another great way to reach out to me. For those who might have logged off early, we can obviously, maybe send a follow-up email to allow those people with just my contact info. But yeah, I feel free to email, even if you're not buying something per se or whatever, you just have a question, whatever, email me. I love hearing about other people's projects. It's kind of mutually beneficial. Hopefully I can share something with you, but you very much might teach me something or share something or a new way to use this for me that I'm always looking for. So yeah, reach out to me.
All right, so if there's no more questions, we can conclude our stakeholder presentation. Spencer, thank you again for joining us and presenting. It was really incredible and insightful, and I'm sure a lot of people were stoked to get this information. So this presentation's been recorded. It will be posted to the Engineering Innovations webpage in the next few weeks. So keep a lookout for that. And if you need anything on the EIG side, feel free to email us at crc.eig@gmail.com or just my personal email. But yeah, thank you so much for being here. And if there's nothing else, then we could all hop off and enjoy the rest of our day.
Thank you everyone for attending. I really appreciate this opportunity, and thank you, Megan and Brooke. So everybody have a good rest of the day or night. Thank you.
Thank you.
Awesome. Thanks everyone. And thank you, Spencer, so much. That was amazing. It was really a great presentation.
No. Thank you. Hopefully anybody who was on here, thank you guys. Hopefully it was helpful. So I'm always happy to share. I think sharing is yeah, we need to do more of it just to inform what each other are doing, whether it helps or not. I mean, there very much could be people doing something that I've never heard of and I can benefit from. So it's selfishly mutually beneficial. But thank you guys very much for working with me last minute and creating this opportunity to share this with everybody. So super stoked. Thanks.
It was
Yeah,
amazing.
it's been a pleasure. Yeah, it really was. And I was getting a lot of messages throughout too, just saying that it was great. And people were really, really excited to hear what you had to say. So, and like you said, like there's a lot of silos in the restoration community. So we do need to communicate with each other, and that's what we strive to do with the EIG. So yeah, once again, thank you so much. And I'm gonna hop off.
Okay, awesome. Thank you guys. Have a good rest of the day.
Bye.
Bye.